In this video, we're going to go over everything that you need to know about friction for the MCAT, and we're covering it specifically in a way that prepares you for MCAT style questions. And this video is part of a series going over everything that you need to know for physics for the MCAT. What we're going to look at in this video is first, what exactly is friction? Then we're going to talk about the two types of friction and what is the difference between those. So that's static friction and kinetic friction. Then we will do how do we calculate the friction force, and lastly, we will analyze some friction problems. First, what is friction? Friction is a force that opposes motion. And to talk about what that means, let's just get right into these two different types of friction. For static friction, this is the friction that opposes moving a stationary object. Let's take this box here that weighs 10 kilograms and it's sitting on this floor. If I start pushing against this with a 10 Newton force, it might not move. And the reason that it might not move is because of the static friction force. The box is in contact with the ground at this highlighted portion. The contact between the box and the floor has a bunch of intermolecular interactions that creates an attraction between the box and that floor. And when we try to push the box this way, it's kind of stuck to the floor. And the thing that we say is sticking it to the floor like that is the friction force. And you want to be able to think about what direction does this friction force point in? The friction force is always going to point in the direction that opposes the force that's trying to move the object. So we are pushing on the box with this 10 Newton force and we're pushing in the right direction. So then the friction force has to point in the opposite direction to resist that pushing. And we'll talk about how to think about the value of the friction force once we go over this third point of how do we calculate the friction force. But for now, let's just talk about the concept of kinetic friction. In this situation, we have the same 10 kilogram box, but this time, let's say it's already moving to the right. So let's say it's moving to the right with a velocity of 2 meters per second. The kinetic friction force is the force that's trying to stop this box from moving, and it also points against the motion. So since the box is moving to the right, like what we see there, that means that the friction force has to point to the left. And just like with static friction, this force is caused by intermolecular interactions between the box and the floor that it's in contact with. Now let's get a fresh page to talk about those next 2 points. First, how do we calculate the friction force of static friction? Let's take the 10 kilogram object again and say that we're pushing on it to the right with a value of 10 newtons again. Let's assume that this object is not moving. If this object is not moving, that means that we have to have a net force that's equal to 0. And that's because if we're looking at a stationary object and then we have a net force pointing to the right, that object is going to start moving to the right. If we have a net force that points to the left, it will start moving to the left. So since we know the net force has to be 0 because it's a stationary object, then that means if we are pushing on this object with a 10 Newton force and we're pushing to the right, then the friction force, which points to the left, has to also be 10 newtons. So the friction force is always equal to the force that's being applied to that object. Now let's say that we start to increase the force that we're applying to this box. And let's say that we end up getting to a force of 40 newtons. And right when we hit 40 newtons, the object starts to move to the right. That means that the 40 newtons must be higher than that friction force that points to the left. But since the box only started moving right when we hit 40 newtons, we know that the friction force, it had to be equal to something that was super close to 40. So let's just say it's 39.9 newtons. And then right when we got higher than 39.9 newtons, this object started to move. We have an equation we can use to calculate that maximum static friction force. So we are not always at that maximum because normally the static friction force is just equal to whatever force is pushing on the object, like what we showed earlier. But then we can reach a maximum, and if you push higher than the maximum, then your object is going to start to move. The equation for that maximum static friction is the force of static friction here is equal to the static friction coefficient. And what this number is just a value that is dependent on the type of object and the type of surface that are in contact with each other. And the higher friction that those two surfaces have with each other, the higher this static friction coefficient will be. We multiply that by the normal force. And I have a video earlier that goes over everything you need to know about the normal force. And again, this is only for the maximum static friction. Now let's look at the kinetic friction. And this box is already moving at 2 meters per second. This one is a lot easier because the static friction is always going to be the same no matter how fast the object is moving. We calculate the kinetic friction by setting it equal to the coefficient, and this time it's the coefficient of kinetic friction times the normal force. Notice how these two equations are super similar, and the only thing that's different is the coefficient. Anytime that you're dealing with the same object and the same surface, just like what we have here, we have the same object and the same surface that are in contact with each other. Anytime you have that, the static friction coefficient for those two surfaces is going to be larger than the kinetic friction coefficient. And the force normal for both of these is going to be the same because that's really dependent on the mass of the object, which is the same for both of these. So since the static friction coefficient is larger, that means that the maximum static friction is always going to be larger than the kinetic friction whenever we have the same object and surface that are in contact. Now let's work through an example problem and we'll apply the static friction and the kinetic friction. With this problem, we are trying to figure out how much force needs to be applied to make this object move. And then once it's moving, we're going to try to figure out what is the acceleration if we apply a 500 Newton force. And for this particular object and surface combination, the static friction coefficient is 0.1 and the kinetic friction coefficient is equal to 0.05. All right, for the first question, which is asking us how much force do we need to apply to make the object move, start thinking about the static friction concept that we talk about. Remember that we will have to exceed the maximum static friction to make this object move. So let's first calculate that maximum static friction. We set the maximum static friction equal to the static friction coefficient times the normal force. To calculate the normal force, we first need to figure out what is the force of gravity pulling this object down. And luckily, that's really simple. We just do the force of gravity is equal to 25 kilograms times 10 for that gravitational acceleration. That then is equal to 250 newtons. So this box is applying and pushing down on the floor with 250 newtons. Since that whole 250 newtons is pointing straight down into the floor and it's perpendicular with the floor, that means that the normal force is going to be equal to that entire 250 newtons. And if you want more information on that normal force, again, check out the other video on that topic. So the normal force that opposes that 250 newtons is also 250 newtons. We're going to plug in 0.1 for that static friction coefficient and multiply it by 250 newtons. That's going to give us a value of 25. That means that 25 is the maximum static friction force. Anything less than 25 will not be able to move this object, but once we get more than 25 newtons and we apply that to this object, the object will start to move. So the answer to this first question is more than 25 newtons. And make sure you understand that if we applied less than 25 newtons, let's say we only applied 10 newtons here, that means that the friction force that opposed that 10 newtons would only be equal to 10 newtons. We only reach that maximum static friction force if we apply a force that's equal to that maximum static friction. Now let's do the second part of the question. What is the acceleration if we apply a 500 Newton force? 500 newtons is way more than that 25 newtons required to get this object to start moving. So if we're applying a 500 Newton force, we know the object is moving. And when the object is moving, we can use the kinetic friction coefficient. And remember that we said the kinetic friction force doesn't change. It's always the same no matter the speed of the object that's moving. And let me erase some of this so that we can work with a clean slate. We have 500 newtons pushing on the object. We have the kinetic friction resisting that motion. So force of kinetic friction. To find the acceleration, we need to find the net force. And the net force is going to be equal to that 500 newtons that we are applying minus the friction force that is pointing in the opposite direction. So we need to calculate that friction force. The friction force, what we talked about earlier, is equal to the kinetic friction coefficient times the normal force. We already calculated the normal force when we did the static friction calculation, and we can just plug in 250 newtons for that. Then we need to multiply that by 0.05 to get our kinetic friction. 0.05 times 250 is equal to 12.5. That makes our kinetic friction 12.5 newtons. Our net force then becomes 500 minus 12.5, giving us a final value of 487.5 newtons. To find the acceleration, we need to do F equals ma. And then we plug in 487.5 equal to 25 for the mass of the object times acceleration. Remember, on the MCAT, you can do some rounding. You could round this to either 475 or 500. Either one should get you close enough for the answer. Let's do 500 just to keep it a little bit more simple. 500 divided by 25 is equal to 20. And we rounded the 487 up to 500, so we are going to be actually slightly less than 20. And that's meters per second squared. So the acceleration, if we apply 500 newtons of force, is slightly less than 20 meters per second squared. If you found this helpful, check out my content library and office hours program through the link in my bio.